current as the circuit variable. Nodal analysis apply KCL to find unknown voltages, while mesh analysis apply KVL to find unknown currents. Okay, so this is the difference between nodal analysis and mesh analysis. Nodal apply KCL to find unknown voltage. Mesh use KVL to find unknown currents. A mesh is a loop which does not contain any other loop within it. These are the steps to determine uh, the step in mesh analysis. The first is to identify mesh. The second to assign mesh currents, name it as I1, I2, and so on. The third is apply KVL to each of the n meshes. Use Ohm's law to express the voltage in terms of the mesh currents. Okay, so we apply KVL in each loop, and then we substitute the equation with Ohm's law. The last is solve the resulting simultaneous equation to get the mesh currents. Okay, let's say this is the circuit. The first step is to identify loops. We have two loops here, so we name it as loop 1 and loop 2. Draw the flow of current, draw the arrow of current clockwise. Okay, name it as I1 and I2. The third step is to apply KVL in each loop. Okay, so remember, and then use Ohm's law to express the voltages. Okay, let's say there is a resistor, current I1 flows like this. Okay, meaning that the voltage drop is positive and negative here. So VR is equal to I1 times R. Okay, this resistor is located like this. Okay, meaning that two currents flow through this resistor. When we do analysis in loop 1, okay, the voltage drop is positive here and negative here, so I1. And then when we do analysis in loop 2, okay, sorry, at the same time, I2 flows opposite to I1, so VR is equal to I1 minus I2 times R. Why I1 minus I2? Because the polarity of voltage drop is positive and negative. It is in line with the flow of I1, so I1 positive, and then I2 negative. Okay, so let's write KVL equation in loop 1. Okay, KVL equation in loop 1. So the loop 1, so you can start at any element. Let's try to start at voltage source V1. So take minus V1. Okay, because we first made the negative, so negative V1, and then plus, this is plus and minus, okay, of voltage drop, plus. Okay, so remember that each element in KVL is voltage. This is voltage of V supply. This is voltage of 1K. This is the voltage of 1K here. Okay, so V is equal to I, R. I1, R, 1K. And then plus 1K. Okay, 1K in the bracket. I1, why I1 positive? Because I1 flows like this. Okay, so I1 minus I2. Why minus I2? Because I1 flows opposite to the I2. So minus I2 equal to 0. And then please rearrange the equation. Okay, so that I1 followed by I2 followed by I3 and so on, and then equal to round number. Usually we have the value of V1 is given. The value of voltage source is given. So it will be round number. And then loop 2, 1000 I2 minus I1 is here. Okay, 1000 I2. Why I2? Positive because I2 flows to 1K here, and at the same time the flow of I2 is opposite with I1, so minus I1. So now I1 is opposite direction with I2 plus 1000 I2. This is 1000 plus I2. The voltage here is 1000 plus times I2, and then we made positive of V2, so positive V2 equal to 0. Please rearrange your equation so that the first term here is I1 followed by I2 and I3 and so on equal to round number. If the round number is 0, so equal to 0. Okay. Um, Please be noted that when you write KVL equation in loop 1, I1 must be positive. Okay. At the end, when you write the equation, this is the final equation for loop 1. I1 must be positive and other I's must be negative. So negative of I2. If you have I3, so I3 will be negative also. Okay, in loop 2, your final KVL equation, okay, I2, because you do analysis in loop 2, I2 must be positive and other I's must be negative. So negative I1. If you have I3, so I3 will be negative also. Okay. This is the original step. Okay, to write the mesh equation. Okay. You can directly write this equation, okay, without writing this step. How? Okay. Loop 1, this is loop 1. Please count how many resistance in loop 1. Including resistance that share with other loop. Okay, so we have 1K here, so the total is 2K. So you write 2K I1, and then minus, must be minus how many resistance share with other loop. Now we have loop 2 share with loop 1, so we have only 1K resistance that share with loop 2, so minus 1000 I2. Okay, if we have other loop which is loop 3, okay, so we will have minus 1000 I3 in this equation. Okay, so let's go to loop 2. You can, okay, same as previous step, you can directly write this final equation, okay, by just counting the resistance in the loop. Okay, in loop 2, how many resistance in loop 2? We have 1K and 1K, so 2K. So 2000 I2 must be positive. And then how many resistance share with other loop? We have 1K share with loop 1, so 1000 I1, and then the sign must be negative. Any question? Any question? Can understand? Can I understand? Can I understand? Any question? Okay, so let's try this. Okay, so this is the previous question. So we have two loops here. So we will have two KVL equation. Okay, let's say V1 is 7 and V2 is 4 volts. Okay. So substitute V1 and V2 and then you can solve this equation by calculator. Okay, using mode equation, or you can solve it manually by simultaneous equation. Okay, so and then we will get I1 equal to 3.23, I2 equal to minus 0.33. Okay, so 3.33 milliamp flow from the source until from the source and then flow through I3 and also flow through this path. I2 flow through this 1K, okay, and also through this path. How about this 1K? It is sharing of I1 and I2. Okay, V out, where is V out? Oh, V out is at the middle. Okay, let's say V out is the voltage at the middle. Okay, so V out is equal to, how to get it? Okay, so this is I2. This is I2. This is I1. This is I1. I1 is here. Okay, so this is, let's say I naught. Okay, so if we apply KCL at node, let's say this is node A, KCL at A. Okay, KCL at A. Current enter the node is I naught plus I equal I1, right? So I naught is equal to I1 minus I2, okay? Here. So V out is equal to I naught times 1K, right? V out is equal to I naught times 1K. So we get this. Any question? No. Okay. So let's go to another example. Okay. So we have how many loops here? How many loops? 2 loops. Okay. So we will have how many KCL equation? We will have 2 KCL equation to find 2 unknown currents, which are I1 and I2. Okay, this is the question. The question asks you to find I1, I2, and I3. This is I1, I2, and here is I3. The first step is to put the I1 and I2 in the loop. Okay, make it clockwise. I1 here, I2 here. I1 here is equal to capital I1 here. I2 here is equal to capital I2 here. Okay. I3 here is sharing of or difference of I1 and I2. Okay. But you cannot simply I1 minus I2 or I2 minus I1. Okay. Please do KCL equation like this. Okay. First, we write KCL equation in loop 1. Okay, so minus 15. Okay, let's start with the supply voltage. Minus 15 and then plus 5 I1. Okay, and then plus 10 I1 minus I2. Okay, I1 must be positive because we write equation in loop 1. Okay, and I2 must be positive. And then we made a positive 10 and then equal to 0. Okay. So this 5I1 is the voltage of 5 ohm. Okay. This is here. It is the voltage of 10 ohm. Okay. And then please rearrange. Put I1 followed by I2 and then equal to round number. Okay, so you can directly write this equation. Okay, in the first line here. Okay, without writing this line. How? Okay, firstly we have minus 15. Okay, you may count resistance first, or you may count the voltage source first. Okay, so how many resistance in loop 1? We have 5 and 10, right? Okay, so 15. So you write 15 I1. And then how many resistance share with other loop? We have only loop 2 here. 10 ohm. Okay, so must be minus 10 I2. And then you count the voltage source. We have minus 15 and then positive 10. Minus 15 and positive 10 and then equal to 0. And then you write this final equation of loop 1. Okay, same goes for loop 2. This is the original step. Okay, let's start with here. So we have 6I2 plus 4I2. Okay, and then we made minus 10 volt. Okay, minus 10 here, and then this 10. Okay, I1 must be negative, I2 must be positive because we now do analysis in loop 2. Okay, so 6I2 is the voltage of 6 ohm, 4I2 is the voltage of 4 ohm, and then this is the voltage of 10 ohm minus the voltage source. Okay, please bear in your mind that in mesh analysis we write KVL where all term in the equation is the voltage. Okay, or you can write like this. Okay, without writing this step. Just calculate how many resistance in loop 2. We have 6 plus 10 plus 4, it is 16. So, sorry, 20. Okay, so where is the 20? 20 is for I2, positive 20 I2. Okay, because now we do analysis in loop 2. And then how many resistance share with other loop? only 10, right? Okay, so 10 I1 must be negative. Okay, so again in mesh 1, I1 must be positive, other I's must be negative. In loop 2, I2 must be positive, other I's must be negative. Okay, next you have two equation and please solve by using calculator only, or you can solve it manually. And finally we have I1 and I2. How about I3? Okay, I3 is like I did previously. Okay, so here we have I1. Okay, because I1 flows at this path, not this path. Okay, and then at this path. So I2 flows here, 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 and then until this path. So this is I2. Okay, so this is I3. Okay, I3. I3 is flow through here. So if we apply KCL, this is KCL. KCL. At node, let's say at node A. Okay, KCL at A. So current entering the node is I3 and I2. So I2 and I3 is equal to I1. Okay, so now we want to find I3. I3 is equal to I1 minus I2. Okay, I1 minus I2 is equal to 0. So 0 M here. Any question? Any question? No. Okay. So the next example, calculate I1, I2 in the circuit. Okay. So we will have to KVL equation to find two unknown currents. Okay. So let's try KVL equation in the first loop. We have minus 12 here, and then plus, okay, calculate how many resistance in the first loop we have. Okay, so this is the express method. Okay, you can also write the original step of KVL. Write KVL equation. Okay, but this is the express method. Okay, minus 12, and then just count how many resistance in the first loop. We have 12, 14 plus 4, 18. So plus 18 I1, and then calculate and then count how many resistance share with other loop. We have I2 only here. So must be minus I2, how many? 12. Minus 12 I2 equal to 0. And then no need to simplify like this. Just leave your equation as 18 I1 minus 12 I2 equal to 12. Okay, no need to write like this. Okay, you may leave your equation as 18 I1 minus 12 I2 equal to 12. Okay, this is your first equation. And then we go to the next, we go to the second loop. So let's count how many. We may start with I1, okay, but I1 must be negative, okay. I1 is the resistance, so 12 is the resistance shared with I1. So minus 12 I1, and then count how many resistance in loop 2. We have 12, 9, and 3. It is 24. Okay, so 24 is 24 I2 positive, and then we made positive 8. Positive 8. Okay, you just rearrange minus 12 I1 plus 24 I2 equal to minus 8. This is your second equation. Okay, and then solve by using calculator. Finally, you get this. Okay, now try, press your calculator. Did you get I1 and I2 like this? Try. Safira, go. Try it now. Did you get I1 and I2 like this? Gogo, try it now. Gogo, are you with me? Okay. Okay. Safira got the same answer. Okay, if I ask you to find, I3, what is I3? What is I3? Iza Afika, what is I3? You can write your answer at meeting chat. What is I3? Iza Afika. What is I3? Same as I1. Oh, okay. Okay, so I1 is here, I2 is here. Okay, if we write KCL here, and then I2 plus I3 equal to I1. I3 is equal to I1 minus I2. I1 is equal to 6.7 milli minus 0. That's why we get 6.7 milli. And it is equal to I1. That's why. Okay. So far, can understand? Okay. Okay. Okay, next we go to another example. How many loops here? We have 3 loops. So we will have 3 KVL equation to find 3 unknown currents. Okay, so the question asks you to find I know is here. Okay, never mind. We will find I1, I2, and I3 first. Then we will look I know by applying KCL at node A. Okay, so we write KVL in the first loop. Okay, this is the original step where we minus 24. Okay, and then 10. Okay, 10 I1 minus I2, and then we have 12 I1 minus I3. Or you can just write like this. Count how many resistance in loop 1. We have 22, isn't it? We have 22. We have 22 I1. And then how many resistance share with other loop? We have 2 resistance share with other loop. Let's start with I2 first. So must be negative because other loop. 10 I2 and then must be minus also. We have 12. 12 I3 and then we have supply here. It is minus 24 or I just write equal to 24. So this is our first equation, okay? So you can, in your final exam or in your midterm test, you can just write this line, okay? And you will get, you will get the full mark for this loop 1, okay? Don't need to simplify like this. No need to simplify like this. Okay, and then we write the KVL equation in loop 2. Okay, this is loop 2. Let's start with I1 or for easier, we just start with I2. Okay, now we do analysis in loop 2. So count how many resistance in loop 2. We have 10, 4 and 24. Okay, so 38, right? 38. Okay, so we write here positive 38 I2. And then how many resistance share with other loop? We have this 10. Okay, so 10 must be negative 10 I1. Okay, and then I3 also must be negative. Okay, so we have 4, right? Share with loop 3. So minus 4 I3. And then is it a voltage source here? No. So equal to 0. This is your second equation. Okay, no need to simplify like this. Okay, so our third equation is here. Okay, so this is the original step to write KVL. Let's write the express approach. Okay, how? Now we are in loop 3. We count how many resistance in loop 3. We have 4 and 12. So it is 16. 16 I3, right? Okay, so 16 I3. How many resistance share with other loop? Let's start with loop 1. We have 12 ohm share with loop 1. So must be minus 12 I1. And then must be minus also for I2. We have 4 ohm share with loop 2. So for I2, is there any voltage source? Yes, we have 4 I0 plus 4 I0. Okay, we have to substitute this I0, okay, in terms of I1, I2, I3. Now we know that I0 is here. If we apply KCL here, so I1 is equal to I0 plus I2. Okay, I0 here. Okay, or okay, so we know that here, but I1 equal to I2 plus I0. Okay, I1 is equal to I2 plus I0. So we can substitute this I0 with I0 equal to I1 minus I2. Okay, so substitute I0 is equal to I1 minus I2. So minus 12 I1 plus 4 I2 plus 16 I3 plus 4 I1 minus I2 equals 0. Please rearrange this, okay? So that you will have I1, I2 and I3 and then equal to 0. And solve for I1, I2, I3 here. Okay, try it now. Did you get this answer? I1, I2 and I3. Try it now. Now press your calculator. Try to get I1, I2 and I3. Did you get the same answer? Same. Okay. So the question asks you to find I0. So I0 is equal to I1 minus I2. So you just I1 minus I2. Okay, same. How about others? Same answer. Okay, no need to simplify to positive I and negative I1 like this, okay? Got same answer. Okay. Okay, the next example. Find I know. Where is I know? I know. Now we know that I know is equal to I3. Okay, Diana. I know is equal to I3. Okay, so now let's write equation in the first loop. You can write KVL equation as the original step. Okay, it's okay. Never mind. Or you can just go to the express approach. Okay, by counting how many resistance in loop 1. It is 6. Okay, 6 I1. How many resistance share with loop 2? We have 2. So must be minus 2 I2. How many resistance share with loop 3? We have 4. So must be minus 4 I3. Is there any voltage source? Yes. So minus 20 here. Rearrange. Okay, no need to simplify like this because we just use our calculator. Okay, so just write 6 I1 minus 2 I2 for I3 equal to 20. So this is your first equation. And then this is your second equation. So 8 plus 2, we have 10. Okay, positive 10 I2. And then how about I1? 2, right? We have minus 2 I2. How about I3? We have A share with loop 3. So minus AI3. Is there any voltage source? Yes. It is minus 10 I0. Okay. Don't forget to substitute this I0. Okay. I0. I0 is equal to I3, right? Okay. So just substitute I0 here with I3. Okay. And then rearrange 2. And then we have plus 10 I2. Okay, so this is I3. It is minus 18 I3. This is your second equation. No need to simplify like this. Okay, we go to the next loop. We have how many resistance in loop 3? It is 18, right? So 18 I3. And then 4 ohm share with loop 1, so minus 4i, and 8 ohms share with loop 2, so minus 8i2. Is there any voltage source here? No, so equal to 0. Rearrange so that your equation will be minus 4i1. Okay, so that it is easier to key in your calculator. Equal to 0. No need to do this. So this is your third equation. Key in your calculator. Finally, you get this answer. And we know that I0 is equal to I3. So just write I0 is equal to I3. It is equal to minus 5 amps. This is our answer. Okay. Okay, everybody. Have you got your breakfast? Have you have your breakfast? Or you combine with your lunch? Brunch. Okay. Well, student like branch. This is the next example. We have two loops, so we will have two KVL equations to find two unknown currents. Okay, so let's write the first KVL equation. In the first loop, we have minus 10, and then, okay, if I can write the express method. So I just count 4 and 6. So positive I1, 10 I1, and then we have minus 6 I2, and we have a voltage source negative 10. So I just write equal to 10. This is my first equation. Okay. Um, this is in loop 1. How about loop 2? No need to write because we have current source here. I2 flows like this. It is opposite with 5 amps. So I2, you can just write I2 is equal to minus 5 amp. Okay. Or I2 is equal to, yes, like this. Okay. And then just substitute I2 is equal to minus 5 in this equation. And you will get the answer. I6 ohm. 6 ohm is equal to I3. Okay. The question is to find current through 6 ohm. Okay, here. Okay, this is I2. And then after you substitute, you will get I1 equal to this. And then I2. So we apply KCL here at node A. KCL at A. Okay, so I1 enter the node. This is I2. Okay, so I1 is equal to I2 plus I3. I1 is equal to I2 plus I3. So I3 is equal to I1 minus I2. This is I1, this is I2, and we get the answer. Any question? No. Okay, actually, mesh analysis is easy. Nodal analysis is easy. Okay, but you can choose either one. Okay, which one is easier to fix with the circuit? Okay, so nodal versus mesh. Choose nodal for the circuit with fewer nodes. Okay, choose mesh for fewer meshes. Okay, network that contain many series connected, more suitable to use mesh. Okay, network with parallel, more suitable to use nodal analysis. Okay, now let's try nodal equation. Okay, by using mesh analysis. Okay, let's say this question in tutorial to number 29. If you use mesh analysis, you will have how many equation? You will have 4 equations to find 4 unknown currents, or fortunately in this loop you no need to find current here because we have 3 amp here, meaning that in this loop, let's say this is I4, so I4 is equal to minus 3, right? Okay, so easy to substitute minus 3 to other loops. Okay, so now let's try. How about this question? We have 3 loops here. So in this question, the question asks you to find a V. Okay, V. V1. Okay, no, now let's try V2. V2 is 2.4 volts. Okay, V2 is 2.4 volts. Okay, let's try. Okay. Okay, let's solve this by using um, mesh. Okay, so V2. Okay, this is the answer. This is the answer. This is example 2.3.2 P68. Okay, so let's try what to find. Okay, so now use nodal and use mesh analysis to find let's say to find V2. Okay, to find V2. Okay, now let's try. Okay, class, try yourself. Challenge yourself to find V2 by using mesh analysis. Okay, try it yourself. Class, get the answer? Class, did you get the answer? Hmm. No, I also get different. Yes, because um we must be very very careful. Okay. I3. So now let's check your answer. Okay. Let's try it together. Okay. My point is, if we are given a circle, okay, we can apply nodal or mesh to find parameters, okay, like current or voltage. Okay, so which one to use? Either nodal or mesh. Okay, up to you, but please use easier method that suit to the circuit, suit to that mesh, that easier to solve certain circuit, that particular circuit. Okay, so last 2 days we solved this circuit by using nodal analysis, okay, to find v1, v2 and v3. Okay, we also can solve by using mesh analysis. Okay, since today we learn mesh analysis, so why not to try to find v2 by using mesh analysis. V2 is equal to I4 multiply with 4. So I4 in this circuit, it is equal to I4, it is equal to, okay, I4 plus I3 is equal to I1, okay. So let's try together. Now I want to check my step, my calculation. Okay, I got the answer. So please recheck your answer. 2.4. Okay, 2.4 volts. Okay, so it is proven that you can use any approach that so you have to choose easier approach, okay, that suitable to that particular circuit. Okay, class? Any question regarding this example? Use mesh analysis to find V2. Let's say we want to find V2. So by using the same method, you can find V3. V3 is here, okay? So V3 is equal to what? V1 is here. Okay, how about class? Okay, can you understand my steps here? Any question? Okay, let's try tutorial. Tutorial 2. Mesh. Find the following. It is same as in your notes. Okay, try number 32. Okay, try number 32. Find V naught. Okay, so in this circuit, if we use mesh analysis, we will have two equation, right? Okay, this is nodal analysis. When we use nodal, we will have only one KCL equation. Okay, only this equation, and then we substitute what is V naught. Okay, what is V naught, and then V naught. This is voltage divider principle. After we get V1, so we can find V naught. Okay, so now let's try using a mesh. Okay, try. The answer is 1.112. Try using mesh analysis. Okay, try it now. Try it now. Number 32. Find V naught by using mesh analysis. The answer is this. Right now. Rosliana, did you get the answer? Okay, class, did you get the answer? Yes. Okay. So get the answer. Okay, now if you get the answer, got the answer. So number 33, find V naught. Okay. Find V naught using mesh. Okay, find V naught. Okay, how many loops we have? There are there are three loops, but loop here we no need to find because we already have the current, the value of current. Okay, you can compare the method of nodal and mesh. Okay, so when you get the circuit, okay, you can solve any parameter, okay, like this, such as V naught or any I or any current by using nodal or mesh. Okay, unless the question specify the method. Okay, let's say the question asks you to find nodal, so you must use nodal. Okay, if the question asks you to find any parameter by using mesh, so you must use mesh. Otherwise, marks can be deducted or 0 marks. Okay, so now let's try number 33. Okay, find V naught by using mesh analysis. Okay. The answer is 20. Okay, get the answer, class. Yasin, have you tried and got the answer? Nabila got the answer. Okay, fine. Fine. We not. Okay. Okay, solve these two equation. Okay, so let's say this is your answer. I1 is equal to 10 amps. I2 is equal to 5. Okay, so I0 is equal to I2 plus I0 is equal to I1. I0 is equal to 10 minus 5 is equal to 5 amps. So V0 is equal to 5 times 4, we get 20 volts. Okay. Any question? Okay, try this. Very easy. Okay, this one. Try this one. Find V of 6 ohm. Find V drop across 6 ohm. Okay, now try. By mesh analysis. Try. Malisa. Okay, Malisa, try this. Malisa, can you try this? And write your answer here. So, Malisa? Okay, this is very easy. Very easy. Okay, how about this question? Also easy. Okay, so let's try. Find I naught. This is mesh. This is mesh analysis. Apply mesh. Okay, how about this question number 3.41? Okay, class. Delapan. Sepuluh dua enam. Hmm. 1.188. Okay. Find I. Find I. Okay. Let's try. Number 3.41. Try it now, class. Apply mesh. Okay. If we use nodal analysis, so how many nodes here? If we use nodal, so how many nodes? How many nodes? If we use nodal, how many nodes? How many nodes? If you use nodal, how many nodes? In this question? Four. Only three, okay? Okay, now let's try solve this by using mesh. Okay, try it now, class. Okay. Follow this I1, I2, and I3. This is supernode. Produk 3. Class, let's try. Okay, class. Now use my equation here to find I1, I2, and I3. What is I1? What is I2? What is I3? Okay. Hamid Muhammad, give me the value of I1, I2, and I3. Okay. I1, I2, and I3. Islam. Islam Ahmad. So how to find I? How to find I? How to find I? How to find I? I2 minus I3. Okay, so this is I2, this is I3. Okay, this is I. This is I. So I3 is equal to I plus I2. Okay, same like Islam said. Okay, so after we get I1, I2, and I3, so we can find I. I is equal to I3 minus I2. Okay. Hamid Muhammad, are you with me? What is I1, I2, and I3? Okay, calculate now by using calculator only. What is I1, I2, and I3? Or others want to paste your answer here? What is I1, I2, and I3? Someone want to share your answer? Okay, let's check. Let's check. how to check? Okay, is this right? What Nabila found? The same, okay? So assume that this is, yeah, the same. Assume that this is right. So, okay. So I2 minus 1.002 6 m 0.1162, and then I is equal to 1.1876. Yeah, same as this. Okay, good. Okay, class. Now, which one is easier, nodal or mesh, or both are easy? Mesh. Yes, mesh is very, very easy. It is very, very straightforward, right? Mesh. Okay, nodal, mesh. Yes, mesh is easy. Nodal, you depends on the question. Yes, nodal, you should know where is the significant nodes. Okay, the first step is to find where is the significant nodes. But in mesh, you can just straightforward. You can just write the KVL equation. But okay, as Asfar said, what method should you use? Depends on question. Okay, depends on question. Let's say in this question, the question did not mention mesh analysis, so up to you. Find I. Up to you. What method you can use any method. Okay. So in your opinion, which one is easier? It is mesh or nodal for this question? Okay. In this question, what's your opinion, Asfa? If you got this question, mesh, yes, because very straightforward. Okay, you just write loop KVL for each loop, and then you can get each I straightforward. Okay, if you use nodal, you must be very, very careful. Okay, so I think that's all for today. Did you find that in this semester you can understand better compared to last year or last week, compared to last year? Okay, did you find that now you understand better? Yes, Alhamdulillah. Yeah. Okay, so yes, is good. Nabila, good. Okay, so I think that's all for today. Asfa, Syukur, yes, go. Don't give hard question. Okay, I think yes, good, Safiras. I think that's all for today. Okay. If you have question, you can just ask me. You can also try another question in that textbook if you have the textbook. Okay. Uh, Challenge yourself. If you want to get the answer, you can just ask, request the answer from me. That's all for today. Thanks for listening to me. Thanks for being with me today. Assalamualaikum. Enjoy your lunch, your brunch. Bye-bye. You're welcome. Okay, guys.